That's about 25,000 years old, and the rocks on below are about 350 million years old. So we're on the Ringabella limestone member of the Cork Formation, and this is just unique to this particular area. So this area has got muddy rocks, mudstones, but within them there are layers and bands of carbonate. They've been folded into synclines, depressions, and anticlines. And on this beach here we have the axis of one of these important folds, called the Ringabella syncline. So the axis there is running right through the middle of this beach. So on one side of the beach, the rocks will be dipping that way, like that, and on the other side of the beach they'll be dipping that way. So we'll have what a structure which looks like that. And that's the axis. So on one side they're dipping south, and on the other side they're dipping north. Carbonate, limestone, is essentially calcium carbonate, and if we find some today, I've got a little bottle of hydrochloric acid, and when we pour a drop on it, hopefully it will effervesce and give off CO2.
Quartz is one of the most resistant minerals. So in a mature sediment, it's nearly all quartz, because everything else is dissolved or disintegrated. But once you get down to mudstones, you've got a lot of clay in there as well.
We're just going to look at this cave.
The small little organic deposits there as well. It will be influenced probably by the amount of nitrates in the groundwater. In the summer it'll be dominated by the fresh water. It's what they call an ecotone. It's where you're getting terrestrial fresh water and sea all mixing together.
Well, a different mineral coming through, I'd say, you know.
Looking at it and just saying it's black is one thing, but to actually say its composition, you've got to take a sample.
Yeah, and it's just on the surface, isn't it?
Is that a mudstone above us there when you're ready?
All this is mudstone. All this.
Even that above us there?
This?
Yeah.
I think so. Well, let's have a look. Yeah.
Yeah. Okay.
It's like shale.
Shale. Yeah.
You have acid.
I've just done the test on this one.
Oh yeah.
Oh, it fizzed very vigorously.
This is to test the rock. He said the rock over there was very strongly. It reacted very, very strongly to the acid.
So there's a carbonate over there.
Yes.
He's come in with a hammer. We could chip a bit from this grey stuff here. With some of this dark, fine rock, you wouldn't know if it had carbonate content unless you tested it.
Okay.
Or you could look under the microscope and you see the little calcite crystals.
Yeah.
What we do in geology to check, we take a sample and then we take it back to the lab. We saw it, a sliver of it, so maybe like an after 8 mint type size. Stick it to a glass slide, and then we polish it down.
Yeah.
And then you can look at, so it's almost transparent, and then you can look at all the minerals which are present. We're on the beach. We're standing more of us about here now, and that's the edge of the cliff with the fields. This is the rock. All here. There's some very black blobs in here. Can you see them?
I can.
Yeah. Well,
yes.
There's one there anyway.
Yeah.
And they are phosphatic nodules, made up mainly from the bones of fish and also parts of the fish poo that have been rolled around on the seabed. Wow. When you go out to the point here, there is a layer which is full of beautiful phosphatic nodules. They look like golf balls. It's called the golf ball phosphatic bed. And that's the base of the Ringabella limestone.
Okay.
And when you section them and you look inside, they're full of radiolarians, Radiolarians are a silicious plankton that lived in the sea. And you can see all of them. They look like little spaceships. They're fantastic. Little spines on them and everything. If you sample those and extract the radioactive minerals, right?
Yeah.
Things called zircons, you can then put them in a certain mass spectrometer and it'll tell you how long ago that ash formed. You know, in terms of millions of years. It gives you an absolute age.
Why is it black, although rather than pink? You know, the sort of pinky mudstone that we've seen.
So it has a lot of clay minerals in it, and it could have organic material in it.
The polyp, the soft parts of the tentacles, sat on top of this basal support and held it attached to the seabed. Then the thing died and rotted away, but it left behind its corallum, its basal attachment.
Yeah.
And all these little lines is where the base of the polyp, the mesenteries, sank down and got embedded in the calcium carbonate base. So imagine that's on the surface, and when you look under, you know, in longitudinal view, it's like that, you know, it's horn shaped. But sometimes they occur in colonies. There's lots of them, you know, not just one. And it forms what's called a colony, a colonial coral. That's a solitary coral on its own.
You're a good artist.
I don't know about that.